Okie dokes. Alright guys, here we have a problem solving video. So now this is a question that involves accident-based reactions. Okay, this is question number 9. You know, a lot of learners, they have been asking me to do this question. So now these questions, guys, are not actually that difficult as much as you think. You need to understand, you're supposed to understand what is basically taking place here. Okay, you're gonna be provided with statement. Try to analyze this statement, try to see what is basically taking place, and the follow-up questions, they are going to be easy as long as you understand what is basically taking place here. Now let us start with question number 9. Okay, now question number 9, this is what is happening. They say two groups of grade 12 learners were given separate experiments to conduct using a strong base, which is sodium hydroxide, and weak acids. There are two of them, which is oxalic acid and ethanoic acid respectively. Now these experiments were done by two groups, but for now I'm just going to start with group number 1. Okay, we're going to start with group number 1, and there is group number 2. Now here in group number 1, let's see what is happening. These grade 12 learners were asked to determine the percentage purity of a sample of oxalic acid. Okay, they were actually asked. Okay, now because now we start with group number 1, I'm just gonna write group number 1 here. For group number 1, grade 12 of grade 12 learners, the learners were actually tasked to determine the percentage purity of oxalic acid, or actually what is a percentage purity of oxalic acid. Okay, but now in order for them to determine this, there are follow-up procedures that you basically need to understand. Okay, now to do this, they followed the procedure below. Let us see. Now it has step number 1. Now step number 1, this is what these learners did. They prepared a standard solution. Immediately you see a standard solution, you know that, oh, a standard solution of sodium hydroxide, meaning sodium hydroxide, it's supposed to have a known concentration. But before we can say this sodium hydroxide, it has a known concentration, it was supposed to be prepared first. Okay, and this is how they prepared it. What did they do? They prepared a standard solution of sodium hydroxide by doing what? By diluting 50 cubic centimeters of sodium hydroxide solution of concentration 0.63 mole per cubic decimeter to a volume of 1 cubic decimeter. You know what is confusing about this? Because I want everything to make sense to you. We are going to convert these units of cubic centimeter. You see here we have cubic decimeter. Remember, we only work here in South Africa, caps for South Africa, we work with cubic decimeter. So we're gonna have to convert this volume to cubic decimeter. Okay, so meaning we're going to divide 50 by 1000. So that means this volume actually right here is gonna be 0.05 cubic decimeter. Okay, now for step number 1, this is what these learners did. Okay, let us understand, let us unpack everything. So step number 1, in order for them to determine the percentage purity of oxalic acid, this is what they did. Okay, I'm just gonna say standard solution. I'm just gonna write it as SD. Okay, not to confuse you. So they prepared standard solution of what? They prepared standard solution of sodium hydroxide. Okay, and then how did they prepare a concentration of sodium hydroxide? This is what they did. Okay, before they do this, listen, this is what they did in laboratory. This is what they found. Okay, they found a sodium hydroxide. They found a concentrated sodium hydroxide with a volume of 0.05. They found a volume of sodium hydroxide to be 0.05 cubic decimeter, and therefore the concentration of this sodium hydroxide, which was concentrated, it was how much? It was 0.63 mole per cubic decimeter. Remember, this volume, it's a volume of sodium hydroxide. It is also a concentration of sodium hydroxide. But remember, these magnitudes were magnitudes for sodium hydroxide, which was concentrated. So from this concentrated solution, they wanted to prepare a standard solution which is diluted of sodium hydroxide. Okay, so now they wanted to prepare a standard solution of sodium hydroxide which is diluted. And then what they did is, when they wanted to dilute this concentrated sodium hydroxide, they diluted with a volume of 1 cubic decimeter, which is true. Now let's compare a volume of this sodium hydroxide to a volume of this sodium hydroxide. The volume here, it is less because it has high concentration, but now the volume here, it is high. That means this standard solution which is diluted, it's supposed to have a lesser concentration, but in this case we don't know what is the concentration of a diluted sodium hydroxide. Okay, so meaning this information right here is for a diluted solution of sodium hydroxide. They prepared step number 1, they prepared a standard solution of sodium hydroxide by diluting this volume of sodium hydroxide, which has a concentration of 0.63 mole per cubic decimeter, to a volume of 1 cubic decimeter, meaning this is high volume. Okay, that means this concentration is supposed to be less, and it's supposed, we say it is diluted, and this diluted sodium hydroxide, it is what you call actually a standard solution. Maybe if we have a titration, we use this concentration for a titration. Okay, that will be step number 1. And therefore step number 2, they said to us, they also prepared a solution of oxalic acid. Oh, they prepared a solution of oxalic acid by dissolving 0.25 grams of the impure sample in 75 cubic centimeter of water. Remember, cubic centimeter already we converted into cubic decimeter. Okay. Oh, step number 2, they prepared oxalic acid, right? They prepared oxalic acid, the solution of oxalic acid. Okay, meaning they dissolved a mass of how much? 0.25 grams within a volume of how much? Within a volume of, remember, 75, we converted into cubic decimeter, we are going to divide it by 1000, meaning it's going to be 0.075 cubic decimeter. Let me confirm. We're going to say 75 divided by 1000. How much is it? Yes, it is. Okay, and then remember, this mass, it's for impure sample. Okay, this is impure mass. Okay, this is impure mass. That's how they prepared a solution of oxalic acid by the mass of that impure oxalic acid is 0.25 grams, and the volume is 0.075 cubic decimeter. And therefore step number 3, they titrated oxalic acid solution against the standard sodium hydroxide solution. The titration required only 40.02 cubic centimeter of the sodium hydroxide solution to neutralize all the oxalic acid solution in step number 2. Oh, now step number 3, this is what they did. They ran a process that we call a titration. Come on, here they did titration. Okay, in step number 3, they did titration, and when they were doing titration, they used most definitely a standard solution of sodium hydroxide and a prepared solution of oxalic acid. Okay, they used sodium hydroxide, which is a standard solution with a known concentration, and therefore you also used oxalic acid, which is in this step, which is step number 2. But now when they were running titration, this is what they have realized. They have realized that the titration required only 40.02 cubic centimeter of sodium hydroxide solution. Oh, during titration, our standard solution, which is sodium hydroxide, only 42.02 cubic centimeter. I'm going to convert it into cubic decimeter by dividing it by 1000. Or during this titration, only a volume of 0.04 cubic decimeter, it was used to reach the end point. for a neutralization to take place. You get my point? Or only this. Meaning, remember, the concentration of this, it's supposed to be the one that we're supposed to calculate there in step number 1, okay? Because it's a standard solution of sodium hydroxide. We only utilize the volume of 0.04 cubic decimeter, okay? And therefore, for oxalic acid, which is H2C2O4, they used all the information from step number 2, okay? And then the equation for this reaction was just simply like this. It's a neutralization reaction whereby a base reacts with an acid to form a salt and water, okay? And now let us do the follow-up questions and see what does this question actually require from us, or want from us. They say define a standard solution. What is a standard solution? It is a solution with a known concentration precisely, okay? In this case, our standard solution, it's sodium hydroxide, and don't forget, it is a diluted sodium hydroxide from the information that was provided to us. That will be our standard solution. How you define it? A solution of a known concentration precisely, okay? That will be 9.1. And then now, to do 9.2, how are we going to do it? Now, let's have a look at the calculation, which is question number 9.2, okay? 9.2, it says to us, calculate the concentration of the standard solution of NaOH, okay? Oh, they want us to calculate the concentration. See, they want us to calculate the concentration of sodium hydroxide solution. Standard. Now we go to our steps, okay? Step number 1. This is what we are actually asked to determine, okay? We are actually asked to determine this concentration. Remember, diluted concentration. Now, how are you going to calculate it? That's a standard concentration of sodium hydroxide. This is how we are going to calculate it. So remember, in laboratory, these learners, these grade 12 learners in group number 1, they got a concentrated sodium hydroxide of a concentration of 0.63 mole per cubic decimeter with its volume of 0.05 cubic decimeter, okay? We are going to use this volume and concentration to determine number of moles, okay? Now, how are we going to do that? Now, number of moles, listen, number of moles of sodium hydroxide concentrated is equals to, we use stoichiometric calculations to determine this, is equals to concentration of sodium hydroxide concentrated multiplied by volume of concentrated sodium hydroxide is equals to, what is the concentration? It's 0.63 multiplied by 0.05, and therefore when we punch this on our calculator, 0.63 multiplied by 0.05, we get 0.0315 mole, okay? Now this is the number of moles of concentrated sodium hydroxide. Now the very same number of moles, we want to determine the concentration of the very same number of moles in a volume of 1 cubic decimeter. Now that means now we want to determine a C, which is a concentration of sodium hydroxide diluted now is equals to how much? Is equals to N over V. Now our number of moles in this case, our number of moles of concentrated sodium hydroxide is 0.0315. But now, if we use a volume of 1, which is greater than that volume, what will be the concentration of sodium hydroxide in this case, which is diluted and it is a standard solution? It's going to be 0.0315 mole per cubic decimeter, okay? So for 9.2, which is for 3 marks, this is how we determine concentration of a standard solution. Remember, this standard solution, which is sodium hydroxide, it is diluted, hence why we use the higher volume compared to before, because before it was concentrated concentrated because it had a volume of 0.05. So now we prepared our standard solution. Now we know what is our standard solution, okay, concentration of our standard solution. And therefore now we move to question number 9.3. okay, we move to question number 9.3. 9.3, it says to us, calculate the percentage purity of the oxalic acid sample for 7 marks. Okay, to calculate the percentage purity for this group, which is group number 1, we have said that to calculate the percentage purity of H2C2O4, we're gonna need a mass of pure H2C2O4 divided by mass of impure H2C2O4 multiplied by 100, and therefore we get what we were asked to determine, okay, from grade 11. Now, in order for us to do that, meaning we need from this balanced chemical equation, we need to determine number of moles, the reacted number of moles of oxalic acid, so that number of moles, we use it to determine the mass of reacted oxalic acid. Okay, so now how are we going to do that for 7 marks? Now this is what we are most definitely going to do. This is titration equation, right? Yes. Now remember, step number 3, when they were doing titration, they added sodium hydroxide of a volume of 0.04 cubic decimeter with a known concentration, which is a concentration that we have just determined here, to an oxalic acid with how much? With a volume of 0.075. Okay, so now how are we going to do that? Now this is what you're going to do first. We are going to determine number of, we're going to use the, you can do it in 2 different ways, but I'll just do it in a simple way. Okay, this is what they're going to do. Number of moles of base divided by number of moles of acid is equals to C of base, concentration of base, multiplied by volume of base, divided by concentration of acid, multiplied by volume of an acid. Okay, we're going to use this question, this formula. This formula is a titration formula, right? And it's a coefficient, it's a stoichiometric coefficient of our compound in a chemical reaction. Now this is for base, and below here is for an acid. So what are the stoichiometric coefficient of base? Now our base here is sodium hydroxide, it's 2. So here we're just gonna write 2, and then for acid in this case is 1, and then here we're just gonna have to write 1 is equals to, what is the concentration of our base in this case? Remember, base is sodium hydroxide and it has a known concentration. Anyway, we have just calculated it. Okay, it's a standard solution. The concentration of base is how much? It's 0.0315, and therefore volume of base in this case is how much? Remember, the one that was titrated for a neutralization reaction to take place by the end of the reaction, which is the end point, is 0.04. 0.04 divided by concentration of acid. How much is concentration of acid? It's basically what we are looking for, multiply by volume of acid. Volume of acid in this case is how much? Is 0.075. okay, and therefore what will be a concentration of our acid in this case? Let us do calculations. 0.075 multiplied by 2, it's 0.15. okay, it's 0.15, and I'm just going to say to determine concentration of this, I'm just going to say 0.0315 multiplied by 0.04 divided by answer. How much is it? We get concentration to be 8.4 times 10 to power -3 mole per cubic decimeter. Okay, now this is a pure concentration of oxalic acid that reacted with a standard solution, which is sodium hydroxide. Now from this pure concentration, now we are going to determine what? Now we are going to determine, or we are going to calculate mass, or you can just simply say calculate number of moles. But now we're going to utilize this. Remember, this is a concentration of H2 C2O4. Right? Now check here. With this concentration, we know that stoichiometrically C is equals to N over V, and therefore let's make number of moles subject to the formula. N is equals to C multiplied by V, okay? And therefore another formula that we know is that N is equals to mass over molar mass, okay? So now if I have to treat this equation to this equation, this is number of moles and this is also number of moles, I'm just going to substitute CV here. So meaning C multiplied by V is the same as mass over molar mass. Now why am I doing this? Now remember, I have just determined the concentration of oxalic acid, which is this, and remember this is a pure concentration, the reacted concentration with sodium hydroxide. So I am going to use that concentration of oxalic acid and the volume of oxalic acid and the molar mass of oxalic acid to determine the pure reacted mass of oxalic acid. But now how am I going to do that? Let us do substitutions first. Now concentration of oxalic acid in this case is how much? Is 8,4 times 10 to power negative 3 multiplied by what is the volume of that oxalic acid. Remember, it was used from step number 2 when we were doing titration. It's 0,075, right? It's 0,075 is equals to mass of oxalic acid, which is what I'm looking for, and the molar mass for oxalic acid. Remember, it's H2, H is 1, just get say 2 multiplied by 1, plus how many carbon atoms do you have? 2, and then the molar mass for carbon is 12, plus oxygen it's 16. I'm going to say 4 multiplied by 16, and then let us do our calculations to determine mass, okay? This over 1, m multiplied by 1, it's m is equals to 8,4 times 10 to power negative 3 multiplied by 0,075. How much is it? Multiplied by our molar mass, which is 2 plus 12 times 12 plus 4 times 16, 16, and therefore our mass will be 0,0567 grams. Now this mass is a mass of H2C2O4, okay? And then this is a pure oxalic acid that we have just calculated. It's a reacted pure oxalic acid out of impure sample. And therefore to determine the percentage purity of H2C2O4 is equals to what is pure of oxalic acid is 0,0567 divided by impure of oxalic acid. The impure of oxalic acid, it's 0,25, okay? Can you see that? It's 0,25, meaning it's 0,25 times 100. And therefore when we punch this on our calculator, we're going to say answer divided by 0,25 multiplied by 100. And therefore our answer here is 22,68%, okay? And therefore that will be a percentage purity of oxalic acid. If you don't understand, just pause the video, rewind. If you do not understand, ask questions. Go to our Facebook page. It's BI-MINDZ Tutoring Program Service, and thank you for watching.